Hey there, this is Robert Kornacki, Head of Research at Ergo and Ergo Foundation Board Member. In this talk, we're going to be talking about Ergo, Cardano, and the extended UTXO model. So, as many of you may know, the UTXO model is something that has been in cryptocurrencies from day one. Bitcoin started cryptocurrencies, and it was the first blockchain to come up with the extended UTXO model. This was one of Satoshi's original inventions, and which you could argue tried to replicate cash kind of on the electronic sphere. So rather than having accounts, which is what Ethereum later on did, the UTXO model instead has these unspent transaction outputs, which is what a UTXO stands for, unspent transaction output. And these have some coins inside. And every time you want to pay someone, you have a previous UTXO, you destroy it, you create a new UTXO, or multiple new UTXOs, and whatever coins are in the old UTXO must be distributed within the new UTXOs that you created. And so in this sense, you have a value transfer where the old UTXO, which you can conceive of as a box, and that's actually terminology that's used in more of the EUTXO space. So you have a box that holds a bunch of coins, which is what a UTXO is. You destroy that box, and then you create one or more new boxes that have a total of coins that was equal to the input. And so in this way, let's say I owned the previous box, and I want to send money to my friend Alice. So then what happens is I have the right to spend my box, because my box, my UTXO, is encoded with my public key on it, or my address. And since I signed with my private key that I agreed to spend this box, this UTXO, then that gives me the power to decide how it's spent. And so in my transaction, I say I'm spending this specific UTXO, and I want to, instead of having my public key, my address, on the UTXO that's created from the destroyed one, instead I say that it's Alice's, and put Alice's public key or address. In this way, we have a method of taking value that I owned, because it had my name on it, now Alice owns because it has her name on it. And it uses asymmetric cryptography, public key, private key cryptography, where if I sign that transaction, it is therefore then valid, because I am the owner, so I have the right to spend it, and I have the right to determine how it's spent. And in this case, it's all given to Alice. And if I have Alice and Bob as friends and I want to split it between them, well, then we can do the same thing where I destroy the input UTXO that has my address on it, and then I create two new UTXOs, one for Alice, one for Bob, and I can split it, the funds, so let's say I had 10 ADA or 10 ERG, then I can split the ERG as 50-50, so 5 ERGs to Alice, 5 ERGs to Bob, or 75, 25, 7.5, 2.5, and so on forth. That, as a whole, is how the UTXO model works at its simplest. All you have is a bunch of UTXOs with coins in it, and so originally that was just Bitcoin, right? And so you transfer Bitcoin through this UTXO destruction and creation method. Bitcoin, as you may know, had Bitcoin script. And Bitcoin script, while being not useless, because there were initial ideas of like colored coins and other more interesting types of projects that were approaching smart contracts and a lot of, dApps and attempting to make this decentralized ecosystem happen. However, Bitcoin script isn't very powerful. And so while it's not useless, it is missing a lot of features. And this is why when Vitalik created Ethereum, he decided that rather than making Bitcoin script more powerful, which is actually not that simple, and there's a lot of questions to be had because the UTXO model is such a novel thing, where the account model is much more like a bank account, like, an entry in a database. This is something that's very well understood in the realm of computer science, and it's a lot simpler to reason about. And so that's why Vitalik decided to throw away the UTXO model, put in this Turing-complete smart contract language, and that's what became Ethereum. However, with the UTXO model, there are a lot of really interesting facets which are thrown away in that process of switching to account-based model. And so right now, we're kind of at the precipice with the latest blockchains that are coming up with truly novel technology, taking this old, in blockchain terms, of 10, 11 years old of Bitcoin, this old model of UTXO, and reinvigorating it with brand new research, and then coming up with how to go from this limited Bitcoin script simplistic UTXO model and then empowering it with new additions to the model itself, plus brand new languages that allow you to build full-fledged dApps. And that's what's really cool, and that's effectively what the extended UTXO model is for both Ergo and Cardano. In other words, what we can kind of visualize Ergo and Cardano for the UTXO perspective is that it's much more of a natural step forward, building on top of the original design that Satoshi Nakamoto came up with. And what's really cool about that is that with the account-based model, we run into many issues that are kind of tied to this more imperative style of programming, where you just have this account and global state. Because in the account-based model, you're effectively creating mutations of data with your transactions. But in the UTXO model, you're effectively issuing state transitions by destroying old data and creating new data. If you know programming, the account-based model is very imperative in style, while the UTXO-based model is very functional in style because of that. And what this means is that some of the inherent downfalls of the imperative model can be seen in Ethereum, and some of the benefits of the functional model can be seen in the extended UTXO model. And this is the really interesting part, as there's quite a few parallels where also in the imperative world, for most people, it's a much simpler type of programming to get into, as it's more pragmatic, one can say, and less focused on key fundamentals. But that has its pluses and minuses. It may be easier to get into, but it doesn't have as much expressibility, and it's more prone to downfalls. While with the extended UTXO model and functional programming, you go back to basics, strong principles, and while it's more complex, you have a lot more power in what you can do to some degree, but also how you reason about the system itself. And so right now, before I jump into explaining the extended UTXO model at a very high level for both what Ergo and Cardano have. What is very interesting, and the last thing I'll say about the high-level overview, is that because the extended UTXO model is much more functional in design, and both ErgoScript for Ergo and Plutus are not Turing-complete languages within a single contract, but Turing-complete across multiple transactions with contracts. What this means is that it's much simpler to do a lot of cool static analysis, like formal verification of what is going on, because we have this much more foundational basis that's more functional in nature, and it's not Turing complete per transaction, meaning we don't have this state space explosion, which makes it very challenging to near impossible to fully guarantee what you are doing is correct. Instead, we have a much more declarative style of writing smart contracts, and our contracts match state machines much more, which allows us to have a lot of benefits. Now, with that all said and done, what is the extended UTXO model? In short, what we had on Bitcoin was quite powerful, and so we actually had Bitcoin script. And so that's a rudimentary contract language. Maybe not a smart contract language, but a contract language on Bitcoin that's quite limited. In the extended UTXO model, what we have are more powerful languages, as I mentioned, ErgoScript and Plutus, for Cardano and Ergo, respectively. And what these do is provide us with all of your basic programming essentials that you come to expect. So you have your if statements, you have the ability to do mapping on lists, you have the ability to do folds, filters, you can check for equality between different data. And so you have the expressibility of your standard programming language to a certain degree, because we don't have Turing complete smart contracts, which is actually a big plus for us, and also why we can make much more efficient claims on contracts, because we know they won't go on forever. And so what we have in the extended UTXO model is this expressive language, whether ErgoScript or Plutus, plus the concept of data and first-class assets. So let's break that down. So we've talked about the language. We have these much more powerful languages. ErgoScript, for those wondering, is much more inspired by Scala, while Plutus is much more inspired by Haskell. In many ways, this changes how the syntax is written, but the languages, at their very core, attempt to evaluate very similar logical propositions in the end. And so they're reasonably different on the user side, but deep down inside, what they're doing is making similar checks. In the first-class assets, this is quite novel compared to Bitcoin, right? In Bitcoin, BTC is the only asset on the blockchain, and that's the only native first-class asset. With both Cardano and Ergo, what we have are native assets. And so these are tokens, which aren't like ERC20 contracts, where in Ethereum, there are no first-class citizen tokens, no native assets. They're just mini ledgers in smart contracts, which makes them quite inefficient, not very powerful, and very limited and restrictive. And you have to pay more in gas fees than if they were a first-class citizen. And instead, in the UTXO model, we have the ability to mint or forge tokens that are native assets that can get treated just like ADA. And there's discussions about how to even implement paying for transaction fees with these assets, And that's already partially possible in Ergo, and there's talks about it in Cardano, and there's ideas for how to do all of this on the smart contract level too. And so there's a lot of cool things that are possible with native assets, which isn't possible in Bitcoin. And furthermore, what is, one may say, not intuitive, is that in the smart contract world, as we mentioned, we do not have Turing complete smart contracts. And so what this means is that there are limitations in that, and if we only had non-Turing complete contracts, that would be actually kind of crappy. But the addition of native assets act as this outside carrier of state and data in smart contract dApp protocols, which allow us to have a lot of guarantees and a lot of really novel and some of the coolest design patterns and innovations we've already found in the extended UTXO model, both on top of Ergo, especially on Ergo since it's already released public on mainnet for over a year and a half now, but also on Plutus and Cardano, is that we can do things that were never possible before in the account model, because with the extended UTXO model and with native assets, we can distribute the state of our dApp instead of being held in one single account with one single smart contract, or maybe just a couple accounts across a few smart contracts, or a few accounts and a few smart contracts. We instead have the entire UTXO set as the potential state of our dApp, and the native assets which are tied to the dApp act as signifiers of proving that you did a specific action in a dApp, proving that an oracle submitted a data point within a given epoch of time, proving that you entered into the smart contract protocol through a valid method, and that this allows you to perform actions asynchronously away from other participants of the protocol. These are all possible because we have the ability to forge and mint native assets that was never possible before. And these native assets, which don't exist on Bitcoin, which don't exist on Ethereum, in themselves have a lot of, arguably you could define them as phenomenological benefits that don't exist on ERC20 standards and anything like them. And so having non-Turing complete smart contracts can be limiting. However, with native assets put together, we actually have what you could argue as a turbocharged smart contract environment. And especially when we add in the last part of this, which is the data. So UTXOs in Bitcoin, they don't inherently carry an area within the UTXO that is relegated for data that can be used within the smart contract. And so you have the ability to post, say, metadata, but you don't have the ability to, say, implement a state of your smart contract, of your dApp, that is carried within the UTXO. And in the EUTXO model, for both Ergo and Cardano, we have data. And this data is slightly different. In Ergo, it's in the form of registers, and in Cardano, it's in what's called a datum. But effectively, they map onto the same thing, where you have this area inside of your UTXO where you can say, where you can keep the state of your dApp. And maybe the state of your dApp is distributed across 5 different UTXOs. And for specific actions in your dApp, you need to spend 2 out of the 5 together to perform, say, minting a token. or you need to use the other three to say perform DAO governance. And what's cool is that you can have some people using those two while other people using those three in parallel. And maybe the state of the three UTXOs all change when they perform governance. And, a specific vote goes through and a parameter changes. And that's all reflected within the data, also known as the datum or registers, respectively in Cardano and in Ergo. And that's where you keep the state and update the state. And this is novel compared to Bitcoin because that wasn't even possible in Bitcoin. UTXOs didn't have this state which can interact with Bitcoin script. But we now have that in the UTXO model. And so, as a sort of conclusion to this talk and presentation, we effectively have this trifecta of native assets, smart contracts, and data within a UTXO. There's a few more parts of a UTXO and some minor differences between Ergo and between Cardano. However, the UTXO model itself is effectively based off of these three parts of a UTXO, and this is what gives it the power that it has. What is quite cool is that we've already come up with a lot of interesting design patterns that were never possible before in Bitcoin, in Ethereum, or in any other system because they've never used the UTXO model. And right now we're at the point where we're really exploring and jumping into what's possible. And so there's already concepts of, recently I came up with potential design patterns for how to work on having asynchronous smart contract protocols. So the possibility of potentially starting a dApp, splitting it into potential sidechains or potential shards, and then having those shards and sidechains only come together and synchronize every once in a while in a very natural way, where even within the shards, the individual actors can asynchronously perform their own parts of the protocols. And so you have this parallelization that can naturally separate, which is never really possible, or while maybe technically possible in the account-based model, very inefficient, would cost a lot, and it's not very clean to do it. And it would be very limited based off of a number of factors. But in the extended UTXO model, we can much more naturally do this. And these design patterns, while still very nascent because this model isn't very popular, we're seeing in our research that there is a lot to uncover. And it is my opinion, and the opinion of a few of us, that these extended UTXO systems, currently we have Ergo and Cardano, the complexity, admittedly, may be a bit more than your account-based systems, because it's a bit different than what most people are used to. However, the power of these systems seems to be a lot more unbounded, a lot more exciting, because the potential here is that you have a brand new model that has effectively all the power of the account-based model, but distributed across an entire UTXO set with native assets, with the ability of your state, of your dApp to be spread across hundreds, thousands, potentially tens of thousands of UTXOs, with the ability to potentially perform asynchronous parts of protocols in separate groups, maybe in different shards, different sidechains. These are directions that are theoretically in our grasp. And while we're not there yet, there's a lot of research and a lot of developer work that we require to get there, we already see a lot of the fruits that are ripe for the picking and which are already going in and starting to harvest. But we also see the fruits that are ripening and even, the native saplings that are just starting to bloom. And some of those saplings will be fruitful, others obviously not so much, as always goes with research. But we're in this phase where we see everything is developing, growing, and we see we have some solutions to problems that are plaguing the account-based world. And that's why the extended UTXO model and the future from a technical perspective for both Ergo and also for Cardano seem very bright, because we really do see there's a lot of untapped potential that lays await in these extended UTXO based systems. And I think, as you'll see in other talks in the Ergo Summit, there is a lot of really exciting things to come, a lot of things we're releasing today. And so I think if you're interested in getting into development, or you're just a user, this is a really great time to try to learn a bit more about the UTXO model, because I really do not think it is going away anytime soon. But in fact, we might start to see more and more blockchains adapting this and moving away from the account-based world, which seems to have dominated for a certain time. But it might be my contention that that may have been that era of blockchains, but as we move forward into the next era, we might be seeing more and more extended UTXO-based blockchains popping up.